The use of HTTPS by default has been increasing year on year across the world's top websites, to such an extent that HTTP probably won't be used that much, if at all, in the not too distant future. So as a developer, you have a duty of care to understand and know how to work with HTTPS within your local development environment. In today's video, I take you through how to set up a custom local domain that uses HTTPS for all your ASP.NET Core web applications. Well, hello, wherever you are, whenever you are, where am I? Melbourne, Australia, as usual, and when is it? It's July 2020. Now I hope wherever you are and whenever you are, I find you happy, safe and well. Now, as I said in the introduction, today's video is all about setting up HTTPS within your local development environment, and you may already be doing that today using LOCALHOST, but in today's video I show you how to configure a custom local domain with HTTPS in order to run your ASP.NET Core web apps. So if that sounds interesting, stay tuned. Just before we launch into the main part of the video, a huge thank you for stopping by. If you like the video, maybe wait until you're a bit into it before you make that decision, then please give it a like. If you've not done so already, maybe think about subscribing, ding the little bell and you'll get notified of all the new stuff that I put up. And to my Patreon supporters who go that little bit extra, huge thank you to you as well. And of course, as usual, your names will be appearing at the end of the video. But I think that's enough by way of an introduction. Let's jump into the video. Alright, well, welcome to episode 4 of season 3, and as mentioned today we're going to be talking about setting up HTTPS with your ASP.NET Core apps. So just an overview of today's tutorial. Just before I go on, I will say the usual things. If you want to jump straight to a specific section I'm going to overview in a minute, there are links below where you can just jump straight to that part of the video. Okay, saves you a bit of time if you don't want to watch the theory part of it. I have written a blog article as well, so if you prefer the written words, jump over and put the banner up below, jump over to the blog and take a look at that. In the description below I've also put links to a couple of other articles which I think I've linked to in the blog as well if you want a bit of a deeper dive into the mechanics of HTTPS and also public and private keys. There's a great article I recommend you read if you don't really understand that fully. We'll talk a bit about it in today's video but not in massive depth. And as usual, the code is available on GitHub. So yes, I'm going through the overview right now. I'll take you through a quick demo of what we're going to build in a minute, and then I'll take you through the ingredients and tooling required if you're going to follow along. Then a very high level HTTPS overview, just what HTTPS, SSL and TLS are, what certificates and authorities are, and then a bit of an interaction diagram on how HTTPS hangs together. We'll then move into the practical part of the tutorial. We'll scaffold up a very simple out-the-box .NET Core API. We're going to use something called .NET Dev Search to set up a local self-signed certificate, and then we'll talk a bit about the drawbacks of that, hence why we're doing this video. So then we're moving on to the main part of the video, which is custom domain, setting up a custom domain. So we'll use our host file to do that. We'll talk a bit about DHCP, and we'll also create and install our self-signed certificate. Try saying that after a few drinks. Just a word of, is it warning? I don't know, but this is a Windows sort of centric tutorial. So by that I mean we actually use PowerShell to create our certificates. You can use other tools like OpenSSL to do exactly the same thing. I'm just not covering that today. So if you're a Linux or OS X user, you may have to do a little bit of side reading on how you create a self-signed certificate in OpenSSL, for example. I might actually, if I can find a good article, I'll put it in the description below as well for you. Next part of setting up a custom domain, we'll talk a bit about user secrets and configuration in general, as well as HTTPS redirection, and then probably the most interesting part of the tutorial, we're actually going to load our self-signed certificate For our custom domain, we'll load it into the Kestrel web server at the start of our application, or our application starts, should I say. And then final thoughts and wrap up. Okay, so let's move on and I'll give you a quick look at what we're going to be working with, or what you'll end up with by the end of the video. So what we're going to do is, step by step, we'll set up out-the-box web API, .NET Core web API, and if you've done that before, you'll know you just get this standard template project that returns back randomized weather data in a JSON payload. So we're just going to use that. But the important point of this video is you're going to run that over HTTPS using a custom domain. So not using localhost like you may have done in the past, but using a custom domain. And there's reasons, which I come on to later, why you would want to do that. So just to give you a quick look at what you'll end up with, HTTPS, obviously, custom domain name. In this case, I've just decided to call it weather.io. You can call it anything you like, and then we just call it in the same way as we would do otherwise. But the important point is we have this custom local domain in our development environment. Clicking on the little icon, we can see we've got a secure connection and we have a valid certificate issued to weather.io by weather.io, so it's a self-signed certificate. So that's what you're going to learn in this video. Let's move on to the next bit. Okay, so the ingredients you'll need if you're wanting to follow along with today's video: VS Code text editor, or any text editor, but I do highly recommend VS Code. .NET Core SDK version 3.1, PowerShell to create our certificates, and a web browser is all you will need. If you want to use something like Postman or curl, that's fine too. So just one slide on what is HTTPS, Hypertext Transfer Protocol Secure. So it's basically just regular old HTTP, but with added security, specifically data encryption. And that data is encrypted. Originally, it was encrypted using something called SSL, Secure Sockets Layer. And today it's now provided, or should be provided, by something called TLS, which is Transport Layer Security. Now, all those things do is they encrypt the data. It's the protocol to encrypt the data over HTTP. The only reason I mentioned it here is you'll hear those two terms used interchangeably, which may technically not be correct, but you know, pragmatically they are the same thing, doing the same thing, just doing it in a slightly different way. So only reason I've called it out, you will hear people refer to one when they really mean the other. Specifically, they will really be meaning TLS, not SSL. All right, so let's talk a little bit about certificates and certificate authorities, or certification authorities. So what is a certificate, first of all? Basically, it just aims to prove the identity of someone. And then that someone, in this case, is a web server saying, I am lesjackson.com, here's my certificate to prove that I am lesjackson.com, and it's not some malicious man in the middle masquerading as lesjackson.com. Now, in order for this to work, certificates aren't generated by the endpoints themselves. They are generated by a third-party trusted authority called the certification authority, and there's a number of those hanging around today. There are third-party companies that are trusted. Now, in today's video, just to contradict myself, we are actually going to be issuing the certificate on our own behalf, because we're just running in our local development domain, so hopefully we basically trust ourselves. But ordinarily, out in the real world, that would not fly. You would need to go to a certification authority to get a certificate that you would then issue to your clients, in this case, web browsers. So clients need to trust these authorities. So you get a certificate, it's been signed by some certification authority. If you don't trust them, then again, the whole thing breaks down. So you need to trust these people. Now, trust is nothing more complex than, you know, are these institutions, are they secure? Are they free from, you know, interventions, third-party oversight, anything like that? And in instances, some certification authorities have been breached, have had security incidents, and basically what that meant was any certificates that they issued were invalid, because you couldn't really then guarantee that they hadn't been tampered with or anything like that. So trust is absolutely critical in this whole dynamic. So what does a certificate contain? We'll go through this in more detail when we come onto it practically. It will contain the domain name, and we're going to create a custom one today, the issuing authority, so that'll just be whoever's issuing it, VeriSign or I can't remember, Komodo and all these kind of guys. What the certificate authorizes you to do. So does it identify you as a client? Does it identify you as a server? Does it do both? Issue an expiration date. And as I mentioned before, public and private keys. We'll look a bit at that when we talk about the interaction diagram. And as I've said before, I'm not going to delve into that too much today's video, but it's an excellent article that I've put in the description below that takes you through how that all works, and I highly recommend that you take a look at it. So just very high level, what are keys? A key is really just a long string. So you can see on screen here the certificate that gets issued down to the client will contain the public key, and you can see here it's just a long string of that's just a long string basically, and it's used to encrypt and decrypt the data. Now, public keys, as the name would suggest, are shared with anybody. So when you get a certificate down as a client, you are given that public key, and you then use that public key to encrypt the data, which you send back over the wire to the server. Now, the only way that that data can be decrypted is using the private key. So private keys are retained only by the endpoint. They must be kept secret, which we are going to endeavour to do here today as well in our demo. And they are the only key that can unlock anything encrypted by the public key. So long as the private key has been kept secret and it's not been shared with anybody, that's basically what gives you that secure connection, certainly from a client to server perspective. The other way around, obviously, the server will encrypt data back over the wire using the private key, and anybody with a public key can then theoretically decrypt that data. Okay, so just a little bit on how HTTPS works. Client, in this case a web browser, server, not web server obviously. So HTTPS connection, this is a client will send it's basically a bit of a handshake. It will send a hello message along with things like the TLS version that it can support and use, cipher suites, which are basically just a set of algorithms that it can support to encrypt data, and something called the client random. Don't worry, we're not going to go into too much low-level detail about it, but it becomes relevant a bit later. The server will then send back very similar type of handshake type information. They're basically just trying to agree on what they're going to use by way of securing the connection. So again, it will send back what cipher suites it supports. At this point, it will also send back the certificate, which contains the public key as well, along with something called the server random. The client random and the server random are basically just strings, random strings as the name would suggest, and these are used later on in the interaction. Now, down at the client end, we've just received our certificate. Now, at this point, this is when the browser will actually check its certificate store to see whether it trusts that certificate. And we'll do that when we come on to actually doing the practical demo. I won't show it just here. But basically, it's just a list of people it trusts, okay? And assuming it trusts one of these issuers that has issued the certificate in this instance, it will then send something called the pre-master secret, which is encrypted with the public key. Now remember when I was talking about public and private keys, you've encrypted some data. Again, it's really just sort of randomized data encrypted with this public key because you trust the certificate, and the only person that can decrypt that data now is the holder of the private key, in this case the server. So the server will get this encrypted bit of data, it will decrypt it using the private key, and then at that point the two endpoints, the client and the server, using the client random, the server random, and this pre-master secret in conjunction, they've exchanged a number of bits of data now. They will then create something called session keys, which allows then for this secure flow of traffic. They've effectively established a trusted, secure connection. And then the data just flows between the two. Now really, in terms of this video, all we're really going to be looking at is this bit here, the checking of the trusted certificate, but I just thought it was worthwhile going through a bit of that interaction diagram. A bit of a handshake, establishing what they can use, a bit of an exchange of data, making sure the certificate is trusted, and then data being encrypted and decrypted using public and private keys. Okay, so we're going to go on and scaffold up the API we're going to use throughout the rest of this tutorial. So I'll just move into my working directory on my D drive and change into episode 4. Now, just before we get going, a quick .NET -- version just to make sure you have .NET Core installed, so running at 3.1, which is what we want. If you don't have that, then just Google .NET Core SDK download and follow the instructions. So to scaffold up a new web API, it's .NET new, and then we pick the template we want, which is web API, and we give it a name using the N flag. Call it anything you like. I'm just going to call it HTTPS test. And that will go away and create our application for us. Okay, cool. So quick directory listing, and you'll see the folder for a project's being created. So I'm just going to open it in VS Code using code-r to open it recursively, and HTTPS, the name of our folder. And that will open our project in VS Code. And we'll probably get a little pop-up down here asking us to restore some artifacts. Just click yes. You'll only get that once. All right, now I'm not going to go through the web API in huge amounts of detail. We're going to go through certain bits, obviously, in detail when it comes to the relevant sections. But generally, I'm not going to go into like what controllers are and stuff. I would expect you know that already. If not, I've done plenty of other videos on web APIs, so check those out. But what I'm going to draw your attention to is this properties folder and the launch settings.JSON file. And in here, basically, there's a number of profiles that basically tell our application how it's supposed to start at startup, depending on where it started from. So if you're running this from within Visual Studio, it will pick a particular profile. If you're going to run it, as we are, at the .NET Core command line, or the .NET CLI, we'll use this profile here. Okay. Now, before we run it up, I just want to draw your attention to this line here, where we have a application URL, and that's basically telling our Kestrel web server, which is our development web server, how it should start and what it should start listening on and what address it should start listening on. Now you can see we have two entries, one for HTTP, starting on localhost on port 5000, and likewise for HTTPS, localhost on port 5001. Now I'm just going to take this out, okay, and you can see that we're separated by a semicolon. So I'm just going to take the HTTPS entry out, Control X, and then Control S to save. So make sure it's saved. So we only have the HTTPS entry, sorry, the HTTP entry in. We've removed HTTPS. So let's get our command line up and running, and that was Control apostrophe, and it's the apostrophe key directly under your escape key. And if we do a .NET run to run up our web API, it will go away, it will run up, and you can see now the Kestrel web server has started and it is now listening on localhost 5000. Again, just to reiterate, we removed the HTTPS entry. So Control and then click on here, it will start your default browser. In my case, I'm using Edge Chromium. Now it's saying the page can't be found because we do need to put in the name of the controller, which in this case is weather forecast. And all that will do is it will retrieve back some randomized weather data, not relevant to today's tutorial, but it's all working. Clicking on this little information icon, you can see the site is not secure because we're just using HTTPS. So that's all good, all as expected. Nice, so let's get rid of that. Let's Control C to kill our web browser, to kill Kestrel. And if we go back into our launch settings.JSON file, if we do Control Z, that should put back, undo our last change, which was to delete the HTTPS entry. We've put it back in. Make sure you Control S to save. Excellent. And we'll try and run our application again. Not surprisingly, we get a horrible critical error, and if you take a look at the exception, you can see we were unable to configure the HTTPS endpoint. No server certificate was specified, and the default developer certificate could not be found or is out of date. So that is really important, okay? So what you can do, and it even actually tells you how to do it, it says to generate a developer certificate, run .NET dev certs HTTPS. And in fact, you actually have to run this one here, .NET dev certs HTTPS trust. So we'll just copy that. And what that does is we'll actually generate this developer certificate for use with localhost. Now, just before we run it, I will bring up the certificate management tool. So type cert into your search box down here. open up this management tool. And this, we're going to do a bit of work in here as well, or we're going to have a look at the various things in here throughout the tutorial. Now this section here, Trusted Root Certification Authorities, if you go in here and click on certificates, when I was talking in the intro about trusted certificates, this is where they sit, okay? Now if we go down here and look for something called localhost, we don't have anything like that. I've got one called local shop, which is one I created for another project. Ignore that for now, but there is no certificate, trusted root certificate for our local host, okay? And that's why we're getting this error, right? So if we go back down to our command line and we paste in that command, .NET dev certs HTTPS -- trust, you will get the security warning. And what it's saying is you are about to install a certificate from a certification authority claiming to represent localhost. So it's a self-signed certificate that we are basically running ourselves and saying we are authorizing localhost to run on localhost. And do you want to install a certificate? Yes, we do. Now if we go back over to our CertMan plugin and do a refresh and scroll down, you will see here that as if by magic, we have this new certificate installed. It allows server authentication, and the friendly name, if we just extend that a little bit, actually, let me open it up. The screen's running at too high a magnitude. If we go to the certification path, we can see it's an ASP.NET Core HTTPS development certificate, which is what that string was there. We can see we're authorized to identify ourselves on a remote computer. So when I was talking earlier about certificates are allowed to do certain things, that's what I was talking about. If we go and look at this other one actually, it will have ensures the identity of a remote computer, and it also has proves your identity to a remote computer. So slightly different. Anyway, this is the one we've created. It's our development certificate issued to localhost by localhost, so self-signed. Now, if we do upkey.NET run, everything's running, and you can see here we're now listening on HTTPS, so control click. It will again fail because we need to put in the name of our controller, so weather forecast. This time it works, and we have the secure padlock. Connection is secure, running on localhost, certificate is valid, and again, clicking on that will just bring up the valid certificate. Now, you may be wondering, that's great, isn't that all we need? Actually, do you know what? Yes, it is. Now, for the most part, this is all I ever use, and it works fine. The whole point of this video, though, it came about, I'll tell you the genesis of it. I was using another piece of software, which I'm making another video for, that required to put in the domain name of an API endpoint in this case, because we're going to route through to it. Now, I used localhost, and the whole thing didn't work. And doing a bit of reading into the documentation of this other piece of software, it said that localhost was not an acceptable domain name to put in this instance. You had to either put in an IP address or a valid domain name. So that's where this video came about from. Localhost as a domain name can be treated differently by web browsers and other applications. It's a kind of special edge case type of domain name. And in the case of the application or the software I was using, it wasn't an acceptable domain name to use. It needed a proper domain name, hence the reason for this video. So in the sections that follow, we're going to go, that's cool, dev certs is excellent, but now we're actually going to come on to creating a custom local domain, create our new certificate, which is a little bit more complex than what we just saw there, install it and load it in to Kestrel. Okay, so the first thing we want to do by way of creating a custom domain is to update our hosts file, our localhost file. What is a localhost file, I hear you say? Let's open it up, and it's probably easier for me to explain it that way rather than doing it up front. Now, we're going to open it in Notepad, just a regular old Notepad, but you'll see here I want to run Notepad as administrator because we won't be able to update the host file if we're not running as admin. So file open. Now, I'm already at the correct location because I've been playing around with this, obviously, but for yourselves on Windows, find your Windows directory, usually on the C drive, System32, drivers, etc, and just make sure you have all files selected. Now you'll see here there's what looks like a couple of host file. If you have this one here, .ics, that's for internet connection sharing or something like that. Do not update that one. It's the other one we want, and I don't believe it's even got an extension. So we'll open up that and take a look. And you can see here that I've got Docker installed. You can see here Docker's actually put in a couple of entries for itself, and what you'll see is the IP address of the local machine, my PC in this case, and then this internal domain name that it wants to use, and it's got another entry there. So we're just going to do something exactly the same. First thing we need to do is find the IP address, which is actually this, to be honest with you, but I'll just show you how to do that in the interest of completeness. So on Windows, ipconfig. Now if, like me, you've got VirtualBox and Docker installed, you'll probably have a load of different network LAN adapters. Make sure you pick the right one, and in my case I'm going to pick the physical wireless LAN adapter, and you can see here's the IP address, which should probably look familiar from the host file, and we'll just paste that in here. And then we can give it our domain name, anything we want. So I think we said we're going to use weather.io. And that's it. So just make sure you save the file, and that's us got an entry in our local host file. Now the only thing to bear in mind here is that if you're like me, you're using DHCP, which is Dynamic Host Control Protocol, from time to time the lease, as it were, on this IP address may expire, and the PC, next time it connects to the network, it may get a new IP address. Now that doesn't happen usually every day. That will happen once every lease period, whatever that happens to be, 3 months, 6 months, or whatever. And you may get the same IP address back, but you may not. So just be aware that the IP address you put in your host file may change, and so if things stop working, just check your IP address like we did previously. Cool. So the only other thing really to test before we move on to creating certificates is just to do a quick ping test. So ping weather.io. And there we go, it's resolving to our local IP address. We're getting a response back. We're all good. Actually, just before we do move on to creating certificates, I did want, the whole reason for bringing this blog article onto the screen is just to quickly talk about hostname resolution order. Now, like we did there when we did a ping test, the first thing the PC will do is check to see whether its local name is being used, and it will resolve it to the IP address that way. If it doesn't, if it's not its local name, its own name, then it will look in the host file like it happened there, and it will resolve it to the IP address we gave it. If not, then it will go to the DNS servers that your ISP is using, and then it will try and resolve weather.io out there in the real world. And then in Windows case, it uses something called NetBIOS, which is an old throwback to Windows NT days, which we don't need to talk about. The only reason I'm really mentioning that is just be aware if you update your host file, then it comes before your DNS server check, so you could potentially end up with some really weird results if you're not very careful. So I wanted to call that out. Just be careful in terms of the order of lookup of DNS name to IP address. Other than that, I think we're ready to move on to looking at certificates now. All right, so the next thing we want to do is actually create our certificate. Now, we're going to do that using PowerShell, so it's important that you have PowerShell available. Now, you have to run your PowerShell session as an administrator. It won't allow you, in the same way that you had to run Notepad as an administrator to update our host file, you have to run your PowerShell session as an administrator as well. Now, I'm using this thing called Windows Terminal, so I'll just search for it. Again, right-click, run as administrator, click yes. And then we've got to type in a number of commands to generate our certificate, which is what I'm going to take you through now. So we're going to make use of local variables because it's a multi-stage process, so these variables just help us out. So the first one we're going to create is to hold our certificate. So that equals new self-signed certificate. And this is this PowerShell commandlet that we use to, no surprises, generate a new self-signed certificate. And there's a few flags we have to pass in here. So cert store location. We just give it a location cert / local machine my. So that's just basically a path to If I still have it running, I should do. I don't. I must have closed it down in between takes. Yeah, it just gives our path to where our certificate is going to sit. But more importantly, we want to specify a DNS name, and this is where we specify weather.io or whatever custom domain you wanted. So we're basically saying we want a new self-signed certificate, want it at this location, and this is the DNS name that we want to verify it for, in this case, weather.io. So at enter, that will go away and create that. If we just have a look at the cert variable, you can see that this certificate is now being created, and there's a thumbprint associated with it, subject, which is basically the DNS name, and a number of things that it allows us to do. Now at this stage, interestingly, where that actually goes, it goes into this intermediate, let me expand that so you can see it, intermediate certification authorities, certificates. And if we scroll down here, you can see it's being created down here. But we're not quite finished yet. It's not, well, you can see here it's not trusted yet. So we need to move this into our root certification authorities, but we've got a couple of other things that we need to do before we do that. All right, so we're in this intermediate stage at the moment. So the next thing we want to do is password protect it. Now, as I said before, as a consumer of or as somebody who's given this certificate, when you make a HTTP request, you'll have access to the public key, but there is also a private key associated with it as well that we need to make or keep secure, and we secure it using a password. Okay, so that's what we're going to do next. So another variable, password, and we're going to use another commandlet called convert to, unfortunately there's no IntelliSense or auto completion here, at least I don't think there is. Convert to secure string, and we'll just give it a password. So make sure you remember what you call it, and it's in between double quotes. Force as plain text. Okay, cool, and that should create our password for us. Again, stored in this password variable. We already have our cert created as well. Next thing we want to create is a cert path. So we use this in our final command when we do our export. So cert, and again, it looks quite similar to what we've already specified above. Cert local machine my. I could have just cut and pasted this in. I didn't want to do it. I wanted you to share my pain. And so we then specify $. Oh my goodness, I'm losing where things are. And then we provide in the actual cert. So again, $cert to reference that. And then we want to reference this thumbprint. So just, can I copy that? I can. Cert thumbprint, so object-oriented notation. And that will create our cert path. Very important, we don't want to overwrite our cert, so this is our certification path. And again, we're passing in the full name of our certificate using the thumbprint. So that all looks correct. We pass that out, and if you have a quick look at that, it will give you, yeah, cert local machine my, and then the name of the thumbprint. Awesome. And then finally, all we want to do is export this certificate for use, and we can use it in various other places. So again, last commandlet, export, and this is a PFX certificate. What is the cert? Well, we pass in the cert path, and then we pass in where we want to export it to. So I'm just going to export it into the root of my D drive for the moment. And I want to give it a name, and I'll call it weather PFX. And most importantly, we provide this password that we created previously, and we pass that in. So let me just double check that before I hit enter and make sure it looks correct. Export PFX certificate, we pass in the certification path for where we can find that certificate. Yep, that looks good. We pass in a file path where we want to export it to, and we give it a password. Cool. And that all looks good. So if we go back to my D drive, actually let's just go, let's do it the command line. you should see this weather PFX certificate file. If you want to have a quick look at that on here, you will see we have a weather PFX file ready to be used by Kestrel. We'll ingest it in, and then we will start issuing HTTPS traffic using that certificate on our local custom domain, and we'll do that next. All right, so just before we move on to coding, something very important that we do need to do before that is to make sure that this certificate or self-signed certificate is actually in our trusted root certification authorities. So very simple to do, very easy to do. Just right-click certificates, all tasks, import, next. Browse to our file name, and we can see here that we need to change this to the PFX type. Extension, select weather PFX, open, click next. Now this is what I was saying before about the private key. We want to make sure that as the owner of the private key, the server in this instance, we keep that secret. Now if you remember, when a client, a web browser, sends us information, they encrypt it using the public key, and the only person that can decrypt that information, so really sensitive information like credit card details or other personal information, is the person with the private key. So that's why we have to keep it safe and secure and password protect it. Okay, so someone else got the hold of this certificate, it means they can't just install it on their server. They have to know what the password is. All right, so hopefully I can remember the password. Looks correct. Keep all other options the same. You can select where you want to import it to, but because we right-clicked from here, it has the right location, which is good. And we just click finish. And you'll get a very similar warning like we got with the dev search tool. Just click yes. Import was successful. So in our trusted root certification authorities, we should have weather.io. Open it up, and it proves your identity to a remote computer, ensures the identity of a remote computer, issued by weather.io, issued to weather.io. All good. All right, so that is up and running now. Now we can move over to our API and do a little bit of coding to make use of this certificate. All right, so let's move back over to our API project. Now, the next thing we're going to do is use something called user secrets. Now, I felt it was appropriate to use user secrets as part of this tutorial because what they allow you to do is keep certain bits of information completely secret to you as the developer on your local development workstation. And why am I talking about this? Well, when we come to ingesting the certificate that we've just created into Kestrel, we need to supply the password like we did with the import into the root certificate store. Now, we could store that password as plain text in appsettings.JSON or appsettings.Development.json, but that's really, really bad practice because it means anybody who has access to your source code has access to your certificate password and in turn has access to your private key. Really bad idea. So even in a development environment, I think it's really worthwhile getting into the practice of making sure that you use user secrets to squirrel off that information into a location that's accessible only to you as a developer in terms of your file system. So it's just a JSON file, it's still plain text, but the only person that can get to it is you based on your Windows login profile, okay? So very important, and I think we should adopt it here. So while it's not strictly necessary to get this working, in terms of best practice, I think it's something we need to do. So enough of my rambling, let's move over and get it working. So move over to the CS proj file, and in here we need to add a couple of tags, user secrets ID, and we will paste that in and close it off. Make sure you terminate it like that. Now, what we need to put in between these tags is a unique ID, and you'll see where this comes into play in a minute. Now, you can do this in a number of ways. You can just Google generate GUID, but I've actually installed a little extension in Visual Studio called insert GUID. It's very useful. I recommend you use it if you want to. And the way you use that is you just place your cursor in between these two attribute tags here, hit F1, type insert GUID, select it, and you can see it automatically generates a list of GUIDs for you. Fantastic. So we'll save that off. Now you're going, why do we need to do that? stick a pin in it for a moment, we'll come back to it. So basically what this is saying is we've got a unique ID for our project and for our user secrets. And then the next thing and the final thing we really have to do is use the user secrets management tool to generate a user secret. So .NET user-secrets set, and then all we do is give it a key or name. So we'll call it cert password. That can be, of course, anything you like. And then we give it a value, which will be a password, or should be a password. And you can see everything is in double quotes. So just to go over again, .NET user secrets, which is this user secrets management tool, and we're going to set a new user secret. Hit enter, and you can see here we have successfully saved this user secret away to the secret store. So where is the secret store, I hear you add? Great question. So let's just open up Explorer. Make sure you have hidden items ticked because it is in a hidden folder. So C drive, Windows, no it's not, C drive users, that's right. And in my case, LesJ, that's my particular user ID, app data. So this is the hidden folder. Roaming, I think it's Microsoft next. I'm really testing my memory here. And then user secrets, there we go, user secrets. There we go. So just to go back over that again, C drive, users folder, whatever your personal, profile folder is. And that means any data under that is unique to you. So if somebody else logs into this PC using a different username, they will not have access to this data, okay? Unless you give them your password, which I don't recommend you do. So yes, LesJ, app data, which is hidden, roaming, Microsoft, user secrets, and then you can see here there are a number of different GUID named folders, and no surprise, as you can imagine, that in each of these I have a different secrets JSON file for all the different projects I've been working on. So if we just go to this one here, which is 28C7, and we find that here, it's here, and we open this up in, I don't know, let's open up in Visual Code. You can see here, secrets JSON, there's just one key in there, one key value pair in there, cert password, password. Excellent, so that's user secrets set up. In terms of retrieving that, we'll come on to that next. So actually, just before we come on to doing the using the user secrets in our code, we do actually need to add another config element. Now, this time round, we are just going to put it into one of our app settings JSON files because it's not a particularly secret bit of information. So all it is the path to our certificate. So back down here, you can remember that we had our weather certificate here in the root of my D drive. We just need to provide a path again when we're coming to ingest the certificate into Kestrel. We need to give it a file path location. Now, there is nothing to stop you from adding another user secret and putting it in there. Nothing at all to stop it, but in my view, that's not really a secret bit of information. So I'm going to put it into one of my app settings JSON files. And all I'm going to do is put it into, because we're really focused in this tutorial within a development environment, I think it's worth, or appropriate, not worth, appropriate putting it into the app settings development JSON file. It's not a production bit of config. So over in app settings development JSON, just comma in there, and we're going to create a new, again, key value pair, and we'll call it cert path, and we'll just give it a path value. In this case, D drive. Got to do double backslash to escape it in JSON, and just the name of the file, pfx. So let's just go back into root of D, and yeah, weather pfx. Okay, cool. All right, so we'll save that off. So basically, we have got two bits of config, path of our certificate and the password of our certificate, which are both stored in separate configuration resource locations. All right, so the next bit and the final bit of our project is we just need to update our code to ingest the certificate that we've created. Now, there's a number of different ways you can do this. I I've gone for this approach. I think it's the most simple, straightforward approach. I think it's relatively easy to understand and it works. So that's why I'm using it. So we're going to do all of our work in our program class, which is quite unusual. I don't usually do a lot of work in the program class, but I do want to update this create host builder method. And that's basically where we're going to override the defaults that we usually give Kestrel. So instead of using the default development certificate for localhost, we're going to tell it to use our new certificate. Now before we do that, this is kind of optional, but I just think it looks a bit nice. So we're going to create a very simple static class just to contain our two config elements. So public static class, call it HostConfig, and it's just going to contain two properties, string, and we'll call it cert path. We'll actually need to make it static. And another property, prop for the short key, another string. Oh my goodness, it's actually quite cold here. We're going into, well, we are in the middle of winter. My hands are cold. That's my excuse anyway. And then cert, fingers can't move properly, cert password. And again, we need to make that static as well. Okay, cool. So just a very simple class. We're going to then read in our config and populate a host config class with those elements. Okay, so the next thing we want to do, as I've said, is we want to read in our config, and we've got two config elements, one in secrets.json and the other one in appsettings.Json. Now, the great thing about the .NET Core configuration API is that you don't actually have to specify that one's in user secrets, that one's over in appsettings.Json, that one's an environment variable. You don't need to specify that. All you need to specify is the key value of your config item, and the .NET Core API kind of figures out the rest. Now, there is an order of precedence in which the configuration API will read in config elements. I'm not going to go into that today, but assuming you've called them different things, you shouldn't have any issue. So over here, again, still in our program CS class, we are going to move over to our create host builder method. And just after create default builder, we are then going to add in another method here, configure services, which probably sounds kind of similar. You may remember, or you may know that we have a configure services method in our startup class usually, but we're going to add one in here as well. And we just need to provide a couple of expressions in here, context and services. This is a lambda. We're going to use a lambda expression going forward. I have to go back here and put context in. And we'll access these expressions in a minute. So lambda expression, I can get it right, curly brackets, and then in here we're going to assign, we're going to read in config and we're going to assign it to our static host config class. So first of all, we're going to say host config, and we're going to say cert path. We're going to set cert path equal to, and all we do is we make use of our context here. And what that does is that gives us access to our configuration, the configuration API, and then all we simply do is specify the key that we want to read in. Now, as I said, the cool thing is we just need to supply this here. We don't need to specify anything else. The configuration API works everything else out, which is really, 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 really cool. So just to go over that again, we've created a configure services method. We are using a lambda expression to access context. That context gives us access to the configuration API, and we're going to read in the cert path, and that's all we need to specify. And we're going to assign that to our little static class here that contains cert path. And in a very similar way, we'll use our host config class, and this time cert password equals context configuration, and then we pass in the name of the key. Now, what was the name of the key? It was probably something like cert password, wasn't it? Let's go and get it again, unless I don't have it open. So users, les_j, app data, roaming, oh my goodness, Microsoft, user secrets, and which one was it? 287C, 287C, there we go, and then we open that with code. What do we call it? Cert password. Okay, copy that in, and we can get rid of that. So moving back over to program, we just provide that key. So again, it's really cool. You know, you've got all these different configuration sources, but the configuration API just resolves it and reads it in. Excellent. So we've now got access to our config elements. Final thing we need to do now is just move into our configure web host defaults and just override some of our defaults with these settings. All right, so the last thing we need to do is configure Kestrel to use our custom certificate or self-signed certificate. So we do that within configure web host defaults. Now, before we do the code, just remind you that in launch settings.JSON, we had this application URL attribute with our options telling Kestrel what port to listen on, what protocol to use for that port, and also the fact that we're using localhost. So just bear that in mind, because we're actually going to overwrite this config here with what we're doing in our program class, and you'll see how that manifests when we run up the application. Cool, so back over in configure web host defaults, we're going to call the configure Kestrel method. Here we go. And into that we'll pass an option, a couple of options to configure Kestrel. Now, the first thing we're going to do is configure our HTTP endpoint, so OPT. Now, to begin with, I'm going to use this method, but don't worry, I'll come back and tidy up in a second. We're going to listen on any IP address, so we're not specifying what IP address we want Kestrel to start on. We're just saying any IP address, listen on port 5000, that's good enough. And we will come back and fix it up with a specific IP address, but I just want to do this bit first. And then the next bit we want to configure is our HTTPS endpoint. So again, listen on any IP address, port 5001 this time. And we want to pass in some additional listener options, or an additional listener option. These boxes are good, but they can get quite annoying. So just to go over that again, listen on any IP for port 5001, we're passing in the listen option, and what is that? That is use HTTPS. And now if I actually just float over and reuse this box, it will configure Kestrel to use HTTPS with the default certificate if available, and it will throw an exception if it's not available. Now, we're not going to do that. We're going to actually pass in our custom certificate. So the first thing we need to supply is the path to that certificate, which is just held in this bit of config. And then the next thing we want to do is pass in the password. Now again, this is kind of, again, speaking to security and the fact that we stored our password in user secrets and we've fed it into our config. It's completely secret, so it's good, it's secure, certainly in terms of a development environment. So that's basically it for now. I will come back and do a couple of tidy ups, but that's basically it. Let me just change back into the right directory. Episode 4. Okay, and let's do a run. Now I'm just going to make this a little bit larger so you can see what happens. .NET run. And it runs, but we get this warning. Now what the warning is, it's saying it's overriding the addresses, localhost 5001 on HTTPS and localhost 5000, because we have, as I've said, configured it in our program class. But nonetheless, it runs up. Now you'll see what it's listening on, because we specified listen on any IP address. You can see here for both 5000 and 5001 that, yeah, that's reflected here. It's listening on any IP address. But nonetheless, it should still work. So if we go over here, I had one prepared earlier. Let me take that out. Let me go home and kind of ruined the surprise there a wee bit. But let's try it again. HTTPS weather.io. It's pre-filled it. So weather.io port 5001. Boom. It all works very nicely. And if we click on the little padlock icon and we click on certificate, there's our certificate, and issued to weather.io. By weather.io. So we've now got a nice custom domain running in our local development environment. So that all works. You could leave it there for now. Two things just to circle back on. number one is HTTPS redirection. So if we go over to our startup class, you will probably have noticed if you've done a bit of ASP.NET programming that within configure, one of the standard things you tend to get now is this use HTTPS redirection. And that means, or basically as it sounds, if we try and hit the HTTP endpoint, my mouse is starting to play up a little bit, I don't know if the battery's running out, HTTP on port 5000 and hit enter, all that will happen is we will be redirected back to the HTTPS endpoint. So it's completely secure. So you're probably going to see more and more of that as we move forward in our lives. Now, the only thing I do want to circle back to, and I wasn't going to do this, I was just going to leave that because it all works, but I felt, I didn't feel comfortable not doing it. We listened on any IP address. Now, yeah, it's okay, it works, but I'm going to show you a very rough and ready way to actually specify the IP address that we should be listening on. So we're going to create a host, and we're going to use DNS. Probably don't have that namespace, so it's going to do that, but let me just fill out the rest of it anyway. Get host entry, and we will pass in. Now, we probably would want to store this in a bit of config, but I'm just going to hard code it in for now. This was a bit of a last minute addition, and this is not correct, so we want to use DNS, not BNS. DNS. Now, it's not resolving, so put your cursor in DNS, control and period, and you'll get a list of things to resolve. And we want to do this using system.net, and that will resolve. So basically all this does is it uses this method here to, well, it uses DNS class to get our host entry name for this host here and put it into host. And then all we need to do is change this listen any IP. I'll comment it out so you can see how it looks a bit different. OPT, instead of listen any IP, we're going to listen, and into that you will pass an IP address and the port. So we're going to use our host IP address list. Now this is where it's a little, it's not that finessed in this case. You could have one or more than one IP address. I'm just going to hard code in the 0 index, which is the first address that will be returned back, and then port 5000. So again, this is not really production level code, but it's just showing you how to get the IP address for our custom domain and listen on that address rather than listen any. For this one, it's pretty much the same. So we'll just do listen, and we will pass in the same thing here. And we should be good. Put a comma in, we should be good. All right, cool. So we're listening on a specific address now that we've derived from getting our host entry. Now again, you would want to put that in a config element, I'm sure. Okay, so let's just do a .NET run just to make sure it looks okay. And indeed it does. Now you can see the difference this time from our previous one where it was just listening on any IP address. You can see now it's actually listening on the IP address that we want. Now hopefully back over here we can just do a refresh and all works fine. Alright, so we are done for yet another video. This video wasn't one I was actually intending to make. It's almost in response to another video that I was making, and I came across this issue and I needed to resolve it. And while it's not the most complicated thing in the world, it took enough of my time up where I thought, well, it's probably worthwhile making a little video on this just to cover it off in case anybody else is having the same issue, or just in case you want to learn about it. Anyway, as usual, if you liked the video, please give it a like. If you've not done so already, why don't you subscribe to the channel and click the little bell and you'll get notified when I put new stuff up. If you don't want to do that, that's cool though, I don't mind. But thank you for watching. Again, to my wonderful Patreon supporters, your names are coming up next. Until then, stay safe, stay well, and I will see you next time.